We've all seen the space shuttle taking off, but most of us take its design for granted today. It wasn't too many years ago that this unusual design shape was considered impractical. That was until a resourceful engineer from NASA named Dale Reed began working on design shapes called lifting bodies, which would change the shape of reusable spacecraft. The lifting body concept evolved in the late 1950s as researchers considered alternatives to the simple ballistic design of space capsules. Many felt that astronauts should have a more sophisticated vehicle that they could fly back and land on Earth from space. The lifting body idea was unusual because the vehicle didn't have any wings. The shape of its body alone had sufficient lift to fly. Despite favorable research on lifting bodies, there was little support for a flight program at NASA headquarters. Engineer Dale Reed decided that a flight demonstration was needed before wingless aircraft could be taken seriously. So, in February 1962, he built a model lifting body and launched it from a radio-controlled mothership in his backyard. While Dale flew the model, his wife took home movies of these flights, which helped Reed convince his boss to give the go-ahead for the construction of a full-scale version. But they would have to build it without funding support from NASA headquarters.
There was very little confidence among NASA headquarters planners of spacecraft missions in the lifting body concept. It was strictly a theory and an idea that a few technical people had. We flight test people felt that if we were to fly one of these and demonstrate that they can fly, then they would be the lifting body would be considered for future designs for future spacecraft.
NASA craftsmen and engineers took on the task and began building this new vehicle that they dubbed the M2F1. It was built with a tubular steel interior frame and a mahogany plywood shell.
We did this on an informal basis. I was allowed to select my team of engineers and technicians that had experience in building home-built airplanes. And we proceeded with the design and construction of the vehicle in that fashion.
Once the vehicle was done, Reed and other engineers towed the M2F1 across the desert runway with a souped-up Pontiac convertible. On April 5, 1963, pilot Milt Thompson lifted the M2F1's nose off the ground for the first time, proving the lifting body concept. Later tests were done with a NASA C-47 that lifted the M2F1 to about 12,000 feet and released it. The lifting body dove toward the ground at 150 miles per hour, but the landing was smooth and the lifting body program was on its way.
That was probably the most exciting thing in my career, with Milt Thompson being released at 12,000 feet, doing a successful flare out of a very steep approach and coming very softly on the lake bed. I feel very proud of the fact that we accomplished a very major milestone in history by demonstrating an airplane that can fly without wings and that can be applied to exciting designs of the future, especially in the spacecraft field.
More than 400 ground tows and over 100 aircraft tow flights were carried out on the M2F1. The lifting body research was used heavily in the design of the space shuttle and is still being used today to design new vehicles like the X-38. The lifting body program has proven to be one of the most valuable programs in NASA history.
During the course of the original lifting body program, 6 different lifting body shapes were flown a total of 230 times, eventually reaching an altitude of 90,000 feet and a speed of Mach 1.86. Coming up, we'll see how NASA researchers are developing new technologies that will make flying safer and more efficient. But first, did you know that the M2F1 was very inexpensive to build? The budget for the project was only about $30,000. In comparison, it is more expensive to operate an F-15 fighter for 5 hours.